Hello, and welcome to your ethics lecture. So while we've touched on ethics here and there and how it applies to certain things that we've learned, we've mostly so far been focused on the algorithms, the math, and the coding implementation of how you actually perform data science. But I now want to talk to you more about what it means to be an ethical data scientist. And unfortunately, being an ethical data scientist isn't something that I can teach you. It's not a checklist that you have to complete. It's not a to-don't list of things that you should avoid. It's more of a process, and it's something that hopefully will continue through your entire career as a data scientist. The other part of this lecture is to watch short videos from people who practice data science in different fields and listen to how ethics impacts their work as data scientists. So this lecture, which hopefully will be very short, is meant to be a conversation starter. It's meant to be a glimpse into how to ask yourself questions and see if you're doing ethical work and improve the ethics of your work. It is by no means meant to be a comprehensive list of things to look out for or things that could possibly be issues in ethical data science. The main thing that I want you to take away from this lecture is that you should be constantly asking yourself questions. While I wish I could give you a comprehensive list of questions, at least I'm hoping to spark in you this idea that you should be asking questions. And honestly, not just of yourself. You should also be seeking help from experts, whether it's experts in machine learning or experts in the domain that your data is from. You should never go about data science alone. Despite what all those Medium tutorials teaching you how to make a deep neural net may suggest, data science should be, in some sense, a collective process where you learn from other experts and you bounce your ideas off of them and ask them and yourself a ton of questions to make sure that the data science that you're doing is ethical. The first scenario that I want to talk about is the 2020 GCSE, which was canceled due to COVID. Instead of holding the in-person exam as normal, an algorithm was developed to adjust teachers' predictions about how well students would do. Theoretically, the goal of this algorithm was good. It was trying to combat things like grade inflation. So it would raise the scores of people when they thought that the teacher was too harsh and lower the scores when they thought the teacher was too generous. But as a result of some of the structure of the algorithm systematically was biased against people with lower socioeconomic status, because those were the people that were more likely to attend the larger state-funded, what we would call public schools, and raised the grades of people in smaller private, very expensive schools. This is a great example of times when your algorithm does things that you don't intend it to. It's really important to look at the results of your algorithm and make sure things like this are not happening, or at least trying to limit the amount that these things happen. Another example is actually something that we've talked about in class before: algorithms that are used in our justice system. For example, there was a system that was used to try and predict recidivism, which is basically when people who are in the justice system might recommit like misdemeanors or felonies shortly after their first one. And this algorithm, even though it didn't have a super large difference in overall accuracy between white defendants and black defendants, the way that the model was wrong between black and white defendants was incredibly startling. The model essentially under-predicted recidivism for white defendants and over-predicted it for black defendants, essentially meaning that the algorithm said that it was more likely than it actually was that black defendants would recidivate, which is a word I just learned reading about this. This is why it is so important to not only look at overall metrics like accuracy, but also look at how your model is incorrect. Are there certain groups for which it is biased? And if so, what can you do to combat that in your model? Now, you all might be super annoyed that when I give you quizzes, I ask questions like specifically, what are the consequences? And I take off points when you say things like the model's inaccurate. It's because of situations like this, where the way that a model is inaccurate for different groups is incredibly important. You have to be specific in thinking about how your model is wrong. Often, overall metrics like accuracy are only the top layer. You really often have to dig deeper. Another point that I want to make is even when people go in with good ethical intentions, you have to be very critical and questioning of yourself to make sure that you're not accidentally introducing bias into your model. For instance, this model was created in order to connect families with public resources and hopefully to combat homelessness. The team that built this model decided that they didn't want to include race. They didn't think it was fair, and so they took out any reference, any column that had to do with race. But when trying to be careful about including information that you think might bias your model, it's really important to think outside of the box. For instance, even if they didn't explicitly include race as a predictor, including things like zip code can often encode very similar information. And you have to be really careful to limit that in your model if you have decided that it is inappropriate to include race. Another point I want to make with this model is that even when predictors improve the predictive performance of your model, like race might in this case, it doesn't mean that you necessarily should include it in your model. If you think that race is an inappropriate predictor despite improving the accuracy of your model, you should definitely exclude it. Another thing to think about is the fact that when you're designing algorithms, you'll often be designing them for good or benevolent purposes. But you have to be cognizant of how the information that you put out there and the models that you build could be used for bad. For instance, you might build a really great algorithm that matches ads with people on Instagram. And while typically that's going to be used to help someone find some shoes they really love or help them find a new restaurant that they end up checking out, you have to think about how that algorithm, which targets specific groups of people, can be used for negative purposes. For instance, often on social media sites like Facebook, people who have lower socioeconomic status or people who are in underrepresented minorities are often targeted with ads that disenfranchise them. Basically, they make them feel like their vote doesn't count or encourage them to boycott voting or even give them incorrect election information in the hopes that it gets in the way of them voting. So even though you designed the algorithm to be good, you should always be thinking about what the potential harm or misuse of your data or your algorithms could be, just like in this case. And the final thing that I want to talk about, although again, this is by no means a comprehensive list of issues that you should consider, is the pale male problem, which is essentially a lesson in extrapolation. Often in things like facial recognition algorithms or medical trials, the data is made predominantly of white men. And this is not inherently problematic, but it becomes hugely problematic when the results of these trials or these algorithms are intended to be applied outside of that group. And that can have really intense real-world consequences. When you build things, it's really important to think about not just does your model do well on the data that you have, but is your data representing well the population of people that it will be applied to? Another huge issue has to do with medical trials. Historically, people who were assigned female at birth are systematically excluded from medical trials because people thought that the variation in hormones that occurs during a person's menstrual cycle could muddy the waters or, obscure medical effects. On the screen, I have listed 3 examples from an article of huge studies that did not include women. And this is problematic because the results of these studies were meant to extrapolate and apply to women and inform their medical care. Looking back, it seems silly to extrapolate results from a study that did not include people that you're applying the results to, but it happened all the time and still has lasting effects on the healthcare that people who identify as women are getting. And this is a huge problem, especially in things like, for instance, heart attacks, which often present differently in women than they do in men. If we don't study those differences, we are likely to make more medical mistakes or not provide a level of care that people actually need. So I want you to be asking yourself, not just does my model perform well on the data that I have, but is the data that I have representative of the population that I want to use this for? Now, I'm going to end this here. This is a conversation that we could have for an entire 3-unit course, but I want to leave you with this. Being ethical is a process. It's not a qualification that you can attain and list on your LinkedIn. It's something that will hopefully continue to be something you work on throughout your entire career of working with data. In the data science community, it can often be easy to focus on the technical aspects, like whether or not you can write SQL queries, or how good your Python skills are, or whether you can define k-means in 5 minutes. But ethical skills and considerations are often overlooked. And my hope as your teacher is that at least you won't overlook it. So I want to leave you with that. Continue to question yourself and reach out to others. Get as much information as you can so that you're making ethical decisions when you're doing data science. Okay, that's all I have for you. I will see you next time.